thank you for being with us today. This call will be, as the title says it, it's about the internet yesterday, today, and tomorrow. So we are all interested to hear what our speakers will have to tell us about it. We have with us on the call our Regional Vice President, Nermeen Saadani. Hello, Nermeen. Know that you're not feeling well and you won't be able to talk. Would you like to say something?
Hello Hannah, hello everyone. Welcome on board. برحب بكم في الكول الريجولر بتاعتنا. I'm sorry that my voice is not helping, but I'm a little bit sick these days. But I'm looking forward for the discussion, and I will be here with you if you need anything as well. Thank you.
Thank you, Nermeen. The moderator for this call will be Jane Coffin. Jane is our Senior Vice President and the head of the Internet Growth at the Internet Society. Jane, the floor is yours.
Thank you, Hannah, and thank you, Nermeen. And Nermeen, wishing you good health over the next few days and weeks. Welcome, everyone from the MENA region. It's a pleasure to be here today, and an even greater pleasure to be very brief and introduce some of our speakers here today. As many of you know, Vint Cerf, VP and Chief Internet Evangelist from Google, is one of the founders of the Internet Society. He has so many accolades behind his name, but he's a very modest human, and will often just say he's part of the ecosystem. But you will hear from Vint, who helped create some of the foundational protocols of the internet and helped us establish the IETF and the Internet Society. Olaf Kolkman, Principal, Internet Technology Policy and Advocacy for the Internet Society, another person with deep roots in the IETF, the internet community, the ecosystem that brings us all together to talk about technology policy development of the internet, building a bigger, better, stronger internet. Olaf works across many of the different teams and provides amazing advice inside the organization. Hosein Badran, Director, Internet Growth and Trust, another highly valued colleague who has come to the Internet Society, who I met many years ago when he was at Cisco and I was at the NTIA working on child online protection issues. So Hosein joins us and he works on many of the different projects across the Internet Society. I'm going to turn it over to our speakers, and from what I know from Hannah, and Nermeen, we have 20 minutes for our keynote speaker presentations. We'll have a panelist discussion of 20 minutes, and I will rely on Hannah to let us know when the first 20 minutes are up, but I'm turning it over to our speakers. And Hannah, help us on the order here.
So we will start with our guest speaker, Vint. The floor is yours for now.
Okay, 1 second while I try to track down the presentation that I wanted to do. What's puzzling me right now is that I think I'm showing you my calendar, which is not what I want to show you.
And your screen has been enabled, Vint, for multiple participants.
Yeah, I'm running into a problem with finding, gee, I apologize for this. It hasn't been this confusing before. I'm trying to find the presentation that I prepared, and I'm not seeing it.
Would you like me to share it from my screen?
If you have it, yes, because otherwise I'll be wasting your time.
Yeah, let me make sure that I can share it from my screen.
I had it all set up as one of the tabs in my Chrome browser, but it didn't look like it came up.
Is that it, Vint? Can you see the screen now?
You need to go back to the first slide. Thank you very much for helping me out here. I think you need to go into presentation mode in order to, up in the upper right there, it's where it says present. To the right. Do you see where it says present? If you drop the, there we are. Okay, and that's fine. Just leave it there. That's the second slide, but that's fine. So this is just to take you back over 50 years to see where the internet's origins were. It started out as a 4-node network. It's 4 different sites in the United States. This was sponsored by the Defense Advanced Research Projects Agency, which was interested in testing the theory that packet switching was a good way of interconnecting time-shared machines to each other to support remote access to time-shared resources and to promote collaboration among a group of universities that were studying artificial intelligence and computer science. So that's where the ARPANET project started. The next slide, I think, jumps ahead quite a distance to 1977. If we could go to the next slide. Actually, this is 1994. This was the 25th anniversary of the ARPANET project, and Newsweek magazine did a small spread about this, and we spent the entire day, John Postel, Steve Crocker, and I, setting up this for this picture. And what we wanted to illustrate was how primitive networking was when the ARPANET project was underway. And so it took us most of the day to string together yellow squash and green zucchinis and coffee tins. And there was a subtle joke here, because you'll notice that this network would never work. It was ear to ear and mouth to mouth, but nothing was mouth to ear. And so we figured the geeks who saw this in the magazine would appreciate the joke. Next slide. So now we fast forward to 1977. Bob Kahn and I started work on the design of the internet, what we think of today, in 1973. And Bob positioned this as a problem of interconnecting 3 different networks: a mobile packet radio network, a packet satellite network, and the ARPANET, which by 1977 extended all the way into Europe using an internal synchronous satellite hop. Intelsat 4A, another synchronous satellite, was used to implement the packet satellite network. The whole point here is that we wanted to show that we could use computers in command and control. That meant we had to show use in mobile vehicles, which we demonstrated using the packet radio network in the San Francisco Bay Area, and ships at sea. Although we didn't have any ships involved in the packet satellite net, in theory you could. We had multiple ground stations sharing the common satellite channel. So we demonstrated that the TCP/IP protocols, which had been evolved since 1973, were capable in 1977 of producing a multi-network communication capability. If you go to the next slide, you'll see an image of what the National Science Foundation network looked like. What's important about this is that once we demonstrated the triple network design and showed it operating, other parts of the US government decided that computer networking was of interest to them. The National Science Foundation built a backbone network and 13 intermediate networks, or 12 or something like that, taking advantage of the multi-network architecture that TCP/IP provided. The Department of Energy and NASA also built backbone networks, and all of them were interconnected with the ARPANET. So the result was, in the United States during the mid-1980s, a rapid proliferation in the academic space and research space of TCP/IP-based networks. In that same time frame, there was a growing adoption of the TCP/IP protocols in Europe and other parts of the world. There were competing architectures. One was called the Open Systems Interconnection Architecture, which was being developed by the Organization for International Standardization. In the end, although there was that competition, there was more implementation of TCP/IP. There was hardware being developed, for example, Cisco Systems, which started in 1984, Proteon about the same time, Juniper later on, and then, of course, the development of software packages for workstations and laptops and desktops and so on. In the next slide, I think we'll see what the internet looks like now, although I'm cheating because this is actually a picture from 1999, but it illustrates the routing tables of the backbone border gateway protocol, just to give you the sense that there are lots of some 75,000 networks around the world that are interconnected. They all choose the hardware and software they want to use. They decide under what terms and conditions they interconnect with other parties. And the whole thing works in a very distributed way. There's no central authority, with the one exception of the Internet Corporation for Assigned Names and Numbers, which is responsible for unique assignment of IP address space and domain names. Next slide. So this is just a list of problem spaces that I consider still to be unsolved. One of them, of course, is dealing with the millions of devices that are going to be programmable or are programmable, and conferring upon them reliability, safety, privacy, security, interoperability, and autonomy, by which I mean if your house is full of internet-enabled devices, you want the house to keep working even if the internet connection doesn't work. You don't want your house to suddenly stop working just because the internet connection broke. Artificial intelligence and machine learning is a topic in the headlines these days, largely out of similar concerns for reliability, safety, privacy, and so on, and also because of the potential for failure because the software doesn't work as planned. More serious problems arise in the social networking space, misinformation, disinformation, and these are hard to defend against, although critical thinking, I believe, is a very important element, getting people to think. Sorry, were you trying to get me to advance faster than I was? Or can we go back? Well, this might be a way of getting me to finish on time. I gather there's no way to go back. Fine, don't worry about it.
No, it was just a mistake. I'm trying to go back.
Well, I think, yes, there you are. If you click, there we are. So we have to deal with the misinformation and disinformation problem, and I don't have any magic pixie dust to do that. It's a hard problem. Digital literacy is more generally about being aware of both the benefits of being online and the potential hazards of being online, and learning how to defend yourself. But people can't defend themselves against everything. And so the harmful behaviors that show up on the net are going to need serious law enforcement responses. And it's going to require international cooperation, which the Secretary General of the UN has called for, in order to track down people who are showing harmful behaviors, particularly harming people who might be in other countries or other jurisdictions. So we need to have some real cooperation on an international basis. As a computer scientist, my biggest concern is that most of the bad problems are the result of bad software with mistakes in them, which get exploited by the bad guys. And so we need to build better tools for designing software that have less bugs in them or in it. And you can see that the consequences of buggy software could be pretty serious when you think about self-driving cars and self-flying drones and robotics and things of that kind. But even the software that you rely on to do your email or to engage in social networking can have negative consequences if the software doesn't work the way it's supposed to. So we have a serious challenge in the research world of building better software development environments to save programmers from their own mistakes. And that leads to the last point on this slide anyway of unfinished business, and that's pointing out that programmers and the companies that employ them should feel a great burden of ethics to do the very best they can to avoid making mistakes in software development and distribution, and also to provide for updating of software in a reliable, safe, and secure way when bugs are found and need to be corrected. If companies that make software-based systems don't have provision for fixing the bugs in the software, in my view, they are exhibiting an unethical posture. Now we can go to the next slide. So all of us on this call are intensely aware of the fact that there is a digital divide, and it's a very broad divide. It's not just about whether you have access to equipment or access to the internet. There are, in fact, major infrastructure deficits where if you have no electrical power available, if you have no communications capability, it's very hard to build a piece of internet. So we need to deal with those deficits. But there are also economic challenges. Making things affordable for people across a significant range of disposable income is an important challenge with regard to reducing the digital divide. There may also be serious policy inhibitors that somehow interfere with investment, private sector investment, for example, or government monopolies that inhibit competition because the government wants to monopolize the provision of either telecommunication service or internet or both. And so we need better policies that will encourage a competitive environment and competitive investment. And finally, you can't run a piece of internet without having people who are properly educated to do it. And so we'd like to have that deficit dealt with in a local way so that wherever we build a piece of internet, there are people available who can run it and can design and build new applications to take advantage of the underlying infrastructure. So those are all part of the going where the internet isn't challenge. Next slide. I just wanted to highlight something that surprised me, and that's the amount of undersea cable that's being built today. This slide is a little out of date, but as we speak, more and more subsea cables are being built, and increasingly even by individual companies. Google is building some of its own cable, for example, for interconnecting its data centers together or connecting itself to internet service providers around the world. We're seeing this everywhere, including islands in the middle of the Pacific and Atlantic being connected by undersea fiber. I had not anticipated that there would be such an intense investment. The data rates are going up as well, and some of our core backbone systems were running at 800 gigabits per second, nearly a terabit per second per channel in the optical fiber. So that's a very important part of our evolving infrastructure of the internet. The next slide illustrates another evolution, and that is low Earth orbiting satellite systems. The number of satellites anticipated over the course of this coming decade are on the order of 42,000 satellites in low Earth orbit, thanks to companies like Starlink, O3b, OneWeb, and Cooper, among others. If this actually succeeds, it will be hard to escape from access to the internet because every square inch of the globe will be accessible by one or another of the low Earth orbiting satellites. So we can anticipate that some of the digital divide will be resolved by the low Earth orbiting satellite offerings. Next slide. I mentioned the Internet of Things earlier. This is just to remind you that we see an increasing number of devices that are programmable that are becoming part of the internet environment. The good news is that they often do some very helpful things for you. The bad news is that sometimes if they're not programmed properly, they can do harmful things. Let me take the refrigerator over in the upper left. I used to wonder, what do you do with an internet-enabled refrigerator? And one possibility is that if it knows what it has inside, it could be surfing the internet for recipes to, for you to make when you get home. So when you come home, you get to see choices that you could make. Of course, if you have an internet-enabled bathroom scale and it's connected to the same network, the refrigerator may know that you're on a diet, and it will put up diet recipes on the display, or maybe it just refuses to open. There are all kinds of other possibilities here. Light bulbs, which we used to tell jokes about, are now programmable and can be controlled remotely. The harmful problem, though, is that these same powerful tools can potentially be abused. So as an example, those internet-enabled refrigerators may be running a full-up Linux operating system in a fairly powerful processor. And if it's invaded by a botnet herder, the refrigerator, which is still keeping your ice cream frozen, could also be generating spam and sending denial of service attacks and other kinds of things. So the Internet of Things is both a help and a hazard, and something that we will have to attend to. I think the next slide just shows a few more examples of possible things you could do with internet-enabled devices. I like the internet-enabled sock. If it has an RFID chip in it, you could actually send an SNMP control message around the house and find the missing sock which announces that it's under the refrigerator in the kitchen or under the sofa in the living room, which is a huge contribution to humanity, the solution to the missing sock. I won't bother going through all of these, just to trigger your thinking about the potential for programmable devices populating the internet in the billions. Next slide. Something that some of you know that I've been working on since 1998 is the extension of the internet to operate across the solar system. This is not a joke, it's a serious piece of effort. If you go to the next slide, you'll see that the project began just after the Pathfinder project landed on Mars in 1997. A group of us at the Jet Propulsion Laboratory began working on a project called the Interplanetary Internet, or the Solar System Internet, which we anticipated would be needed 25 years later. And here we are nearing 2023 and anticipate a return to the moon and also a mission to Mars during the 2030 period, during which we will need this interplanetary backbone. Next slide. So here I'm just reminding you of all the various rovers that have landed on Mars since 1997, not counting the earlier landing in 1976 of the Viking landers. These are all using store and forward networking, which we had to implement in order to get data back from the rovers that landed in 2004, and all the subsequent rovers have been using similar prototype interplanetary software in order to return their data and to accept commands from the research scientists. Next slide. If you're interested in the possible evolution of an interplanetary backbone, please come to visit the Interplanetary Networking Special Interest Group, which is part of the Internet Society. This report, if you go to it, will summarize what it might look like over the course of the next 100 years to evolve an interplanetary backbone, which would include commercial interests as well as government and private sector research, all of which we anticipate will be driven by a real interest in expanding commercial activity beyond planet Earth and beyond near Earth orbit activity. So that report is readily available if you just use the URL that you see here. I think that may be next to the last slide. What's the next one?
I guess this is the last
Is that
slide.
the last one? Okay, that's fine. I have one more slide in a presentation like this one. It talks about a mission to Alpha Centauri, but I think that's well beyond the scope of today's discussion. What's important is that the internet is now very much a part of our society, and all of its benefits and its challenges need to be confronted, and the Internet Society and its aligned chapters and members should be very much involved in solving the problems that I've hinted at here. I think, Olaf, you have some things to say about the proposals for new variations on internet concepts, so I won't go into that, but I'm happy to answer questions now or later in the course of our conversation, and I hope I manage to stay more or less on time.
I think you're perfectly on time, Vint. And what we have lined up is 20 minutes of panel discussion, and you've teed up one really great issue for Olaf. And then we have 20 minutes of Q&A after that. So Hanna will rely on you to sort of give us a 2-minute warning when we're close to the end of the 20-minute panel discussion. I want to frame a question that you raised, Vint, for Olaf, with respect to what you just left us with, which is the internet is part of society and everyday life now. Years ago, in the yesterday of the internet, this may, of course, have been something one had hoped for, but now we have arrived where the internet is with us, and hopefully will be with us into the future in a more robust manner, depending on collaboration among parties, technologists, governments, civil society, and other actors. Olaf, do you want to take Vint's question? Because you do have some thinking on that. And then I would go to Hosein after that with a different question for you all to think
Yeah,
about.
I can. So I can say a little bit about the way that the internet could evolve. The evolution of the internet is an ongoing thing. When the internet was invented, Vint was there. The data rates were very low, and the applications on the internet were, I would say, very few. You had FTP for file transfers, for getting information from one computer to the other. Email was one of the most proliferant applications around. But as the internet evolved, as the capabilities of the network evolved, and the individual networks started deploying other technologies, they went from copper to glass to Wi-Fi and all kinds of other technologies. The applications on top of the internet that use the internet to interconnect, they evolved as well. And they keep each other in balance, where there were more possibilities, more applications, more demanding applications started to make use of the network. And I think that is something that we had never predicted.
Well, no, wait, I'm sorry, I feel compelled to point out something, Olaf. When Bob Kahn and I were doing this work way back in the 70s and the early 80s, we already anticipated at least video conferencing and voice communications, because we introduced those capabilities in very modest amounts because of the data rates. But we were anticipating that because we wanted to build a command and control system, at least a basis for a command and control system. So some of those things were anticipated. But I want to emphasize that the system has managed to scale up by a factor of 6 to 7 orders of magnitude in many different dimensions with the incorporation of new technologies, as you correctly point out. And that is one of the astonishing things about this particular architecture.
Yeah, that's indeed a point, because I doubt whether you had anticipated that everybody would be walking around with one of these, doing exactly the type of thing that we're doing now with a video conference with people all across the globe. But the internet evolved and scaled in that way. And I think one of the properties that allowed that was sort of having a common protocol to which people build their networks and applications could program themselves. So evolution itself is one of these key parts of the internet by which it can grow, by which it can scale. And one of the things that I'm worried about, and you mentioned new IP, somebody mentioned that a little bit, and Hosein will talk a little bit about that, is its revolutionary nature. It says it can do much more things, and it can do so by design. You only have to build it and implement it, and then it's all magically there. That's a promise that we don't know whether it can be kept. And the evolutionary route, I believe, is a more steady route. And the critical properties of the internet, which I can talk a little bit about more in a minute, are ways to look at what are decisions that would allow that continuous evolution of the internet, would preserve its nature. Thinking about a set of critical properties might help you make decisions about the internet today and its future. You're laughing, Vint. Why?
Laughing because I just noticed the comment that you made earlier saying that when I was talking about the missing sock, you thought I was talking about the security operations centers.
Yeah, that's
sorry about that.
Well, that is often a question that people ask, right? They're like, why wasn't that built in? But I think Vint, you and Bob and Olaf and others who've been working on the different iterations of the internet have, you weren't thinking that certain things had to be built in right away, yes? You knew you could layer that in.
That's correct. And it's true for security, for example. I knew that we were going to need security because we were building this, designing this for the Defense Department, command and control. Clearly they needed security. But I also noticed that public key crypto had been invented just about the time that that demonstration of the 3 network thing was being done. And they said, you know what, we're going to retrofit that. And so we didn't put it in right away until we could test the other properties of the internet, specifically for scalability. So, so the answer is yes, we carefully designed this so that we could add new features. And in truth, what Olaf says is exactly right. The architecture has permitted remarkable evolution over time.
And so that concept of this being architected in one way, but now being for a common good for all people, right? Everyone's able to use it. It's not just designed as it was designed back then, but it's had this amazing flexibility and innovation, as you often say. Olaf, could we go over to you on the critical properties and then hop over to Hosein after with respect to new IP, because I think you could help us lay that foundation, building on what Vint has said with those critical properties. And then we can take a look with Hosein at something that was, triggering a little bit of some questions about the critical properties and why, not questions about them, but questions about thinking about why they were so important. So Olaf, how about back over to you?
Yeah, see, and this is where I changed my screen so you can sort of see them on top of myself or behind myself. We did some work over the last year at the Internet Society, actually thinking about that question. What if somebody proposes a change in policy or a change in architecture or a change in thinking about the Internet? And how could we assess whether such a proposal is a good thing for the Internet or a bad thing for the Internet? And as such, we defined 5 critical properties. They're listed behind me. And they are sort of the goalposts. And we are not completely at the perfect state of critical properties, not at all. There are reasons why we're not there. But what we want to make sure is that when you make decisions about the Internet or something that could impact the Internet, that we're not moving away from those critical properties, that the state of the Internet doesn't become weaker. Because if you take a scale, so to speak, and you move all the way back to the end, at some point you might not have an Internet anymore, and you might be in a world that doesn't have all those good things that the Internet has to offer. Obviously realizing that the Internet also brought us some bad things, some bad shit, I was about to say. The 5 things that I want to point out are an accessible infrastructure with a common protocol. The common protocol being the IP protocol. And here you already see that we're not at the complete end of that spectrum, because there are 2 forms of IP, IPv4 and IPv6. I won't go into the details, but that has to do with growing the network to more than 4 billion users. The accessible infrastructure actually means that you can build a network, a new network, connect to the Internet, and become part of the Internet. This is how communities build their own network. Then there is the open architecture of interoperable and reusable building blocks. That means that you can, that brings you permissionless innovation, the idea that you can make an application using components of the Internet, a security layer, TLS is the protocol name. You can use that. You can use web technology and you combine that and you can build all kinds of nice applications on top of that. And by doing that, invent new stuff without having to ask permission. This is how good things, or maybe not so good things, it depends on your viewpoint, but distributed ledgers, blockchains, and so on and so forth came into existence. People used building blocks that were already there and deployed them on the Internet. And nobody had to ask anybody permission to develop and come up with the idea of blockchains. Decentralized management and a single distributed routing system. This is something that Vint already talked about. 75,000 networks that all make their own independent decisions about how they manage their networks, what they invest, and so on and so forth. And one of the things that brings is indeed that you can invest a little bit in a little bit better infrastructure than your neighbor and compete with that neighbor. And as a result of that competition, the whole of the internet becomes better and offers more capacity. The individual choices of those management of those networks helps you to move the needle and scale. Common global identifiers. Making sure that when you try to assess a resource on the internet, a service or something, you at each point on the globe, you reach the same thing. The fact that we have a global network is mainly because we have common global identifiers, specifically the domain name system, the things that make up domain names like www.internetsociety.org or www.google.com. And finally, and this is important too, technology neutral general purpose network. The internet was not designed to do one thing very well. It was not designed to steer 20,000 robots on a factory floor in real time. It was designed to do many things and do them well and do them okay, but not to optimize for one particular purpose. And that makes the internet a very versatile thing. People often say, well, it doesn't have quality of service and so on. Well, it has sufficient quality of service for us to do a Zoom meeting now. And for you to hear me in my natural voice without, weird filters and strange sounds as if I was on a telephone. You can actually see me and you see me move. So there is sufficient quality of service to do that. Maybe there's not sufficient quality of service for me to operate somebody if I were a doctor, to operate on somebody in the Middle East. Not only because there is a large distance between me and the Middle East, and signals just take time because of physical properties. So that's sort of the 5 critical properties. And we have developed a tool set, the Internet way of networking, that you can use to look through these lenses, the lenses of the critical properties as proposals. And if you want to know more, I will paste the link to the chat box in a minute. Back to you, Jane.
Thank you, Olaf. That was fabulous. And I want to pick up on the point you made about the critical properties as Olaf has articulated and the general purpose network that the internet is, and segue over to Hosein. Hosein, what happens when someone proposes something that may not help with the general purpose network design, when they propose something that may break that? I'm thinking of new IP and some other things, but I want to turn it over to you because you have some insight for us.
Yes, thank you. Thank you so much, Jane. And this is really a very critical point to mention that some proposals that particularly that go to standardization, international standardization bodies, aim at revolutionizing the global internet architecture and making it really start fresh with a clean slate. And every kind of investment that took place in hardware and software and network deployments globally will be put aside, and we start with a clean slate of deployment. And the case in point here is the new IP proposal that was submitted by Hawaii to the ITUT back in September 2019. And if you allow me, I can elaborate a little bit on that, what this proposal entails. And I can share a screen that shows a diagram. Basically, the proposal calls for a new set of proposals to develop new network protocols and architectures by extending and redesigning the traditional IP, supporting new services for a new internet by 2030. And here, the idea, as explicitly mentioned, is to come up with a new global architecture. And this global architecture contains specific elements that are being proposed. New kind of addressing, referred to as semantic addressing, and the support of deterministic services globally, along with other requirements of high throughput globally and also minimum delay globally. And these requirements will have a tremendous effect on the global internet architecture. If we take, for example, the multi-semantic addressing requirement that the proposal has put forward, it calls for a new kind of addressing that does not only include the IP address, but also information about the sending party, an ID of the sending party, ID of the receiving party, information about the protocol and the information to be sent, and also information about the guarantees in terms of bandwidth and delay that network has to offer before this communication is accepted. So completely new kind of addressing scheme that will put the points of interoperability that were mentioned before at a great question. And hence any kind of deployment with this kind of protocol stack or architecture will not be backwards compatible with the existing internet as we know it. Hence, we need to introduce control points in the network, which are gateways that will translate between protocols, and this is significantly downgrading the performance of the internet of a global basis, so also the reachability of the internet on a global basis. Not only this, but there's a requirement for deterministic forwarding, which means that I deliver guarantees for traffic, not only to have an acceptable delay limit, but also to arrive in time and on time. And the delay values that are being required by this proposal is in the fraction of microseconds. And this fraction of microseconds really puts a limit on the distance that can be traversed by this traffic, making the network at best a regional network, if not only a local network. So there are significant deficiencies in the proposal that put at risk interoperability with existing infrastructure, and also the reachability of these services, and puts at question the original premise that specific services are required that require this amount of bandwidth. For example, a holographic communication, which is 3D projection, is required on a global scale between all parts of the world. It can be accepted that perhaps some specific deployments require holographic communication, but does everybody globally, the 6 billion people, require it? And do we have to redesign network to accommodate for this on a global basis? So the issues of lack of interoperability, guarantees of very difficult metrics of performance to be delivered, and also it put a constraint on the governance of the network. With such information being conveyed about the user, the ID of the user, about the protocols of being communicated, certainly the governance of the network that is taking place today, this model has to be modified to a different kind of governance structure, where specific entities will have much more control of the traffic and the users associated with this traffic, and have visibility for other purposes on this kind of traffic exchange, which is really quite questionable at best.
Feels a lot like calling line identifier and other things being added to the internet that just feel like the telco network overlay that we've seen in some other places, Hosein.
Yes, absolutely.
Yeah.
Absolutely.
And Vint, it makes me wonder if we're going where the internet isn't, if we start to layer on so many things that this network, this new idea of the network should do, and we start to break things, but we may break things, but isn't it going to be harder to deploy potentially? Wouldn't you think, to other people around the planet? Economic barriers, maybe. I'm looking at your slide and we're going where the internet isn't. With this new IP and or more layering in from this proposal, create barriers to deployment?
Well, plainly, a huge amount of investment would be required in order to implement new IP. I mean, it has concepts that are quite different from the internet's structure. I think probably the two most important things that I think are worth preserving in the internet is this connectivity, that anything can talk to anything else, but it doesn't have to. And the second one is this idea that the applications are understood at the edges of the net, but not in the core of the net. This kind of design, in a sense, forces you to alter the network in order to accommodate new applications, whereas the internet was designed not to be changed, but rather to take advantage of its growing capacity to support new applications, simply by changing some of the parameters, like the speed at which the data can be transmitted. I might also point out that some of the aspirations of new IP would require a level of cooperation and collaboration among the networks which exceeds anything that we've been able to accomplish in the past. We had type of service capabilities encoded in the internet protocol structure, in packet structure, but we've never been able to get multiple networks to agree on exactly what the implications are, either from the technical point of view or from the financial point of view. If you send a high priority multicast packet into somebody else's network and it consumes lots more resources than it did on yours, is there a compensation for that? And no one has been able to sort out a business model that allows these different networks to come to a common agreement. And so rather than imposing aspirations, which new IP seems to require, I think we're better off continuing to evolve the internet in the directions which it has been shown capacity to evolve and to introduce new applications as those capacities permit.
Thank you for that, Vint, Olaf, and Hosein. We're at that mark of from the panel side and moving over into Q&A from the audience. Olaf,
I actually would like to drill a little bit on that point that Vint just made. So you have the internet, which is this network of, say, 75,000 different networks that are all interconnected with each other. And the miracle is that if I connect here as a person and I want to send a packet to another person that is on the other side of the network, that the network that I connect to, this one here, only has a business relationship with its neighbor. That's the only business relationship that that network has. Should I want to have quality of service across all these networks, then this network has to make business arrangement with all the networks that could be potentially on the path between me and the other person in China. That doesn't scale. That's why quality of service on the internet is incredibly hard.
That's why best efforts have turned out to be actually the best design that we've been able to come up with. And look what it has done. I mean, here we are. We're enjoying exactly the consequences of that design.
And it's so easy to implement in many ways that it has become ubiquitous due to the way it was architected and those principles that Olaf was talking about. It's wonderful because we've got so many people around the world connected to this call, and it's just proof positive of.
Well, except that it isn't ubiquitous yet because we're only about half done, and so our challenge. We need to solve the investment problems and the infrastructure problems and the cost problems and everything else. But we've been able to do that for 4 billion people. We can do it for the next 4 as well.
With you, Vint, and that's something that's near and dear to my heart and many of the team at the Internet Society and in our chapters. And how do we look at the policy and regulatory environment to allow for more network development? How do we look at investment? And I've been on several calls and panels with Vint interfaces. We've talked about the importance of new ways of looking at investment and financing. So for those of you on the call, different business models to allow for different business models, different ways to invest, and to bring in more innovative financing, because we can't continue with some of the current policy and regulatory ways of working because it's just not getting to the next 3.5 billion. And we've got a lot of work to do, but there's some really great ideas out there about how to do this and bring more people online as they like. Some people may not want to be connected, but there are a lot of people out there who do. The pandemic has also shown us that the internet is even more important for people. And we've seen people roll out networks or entities roll out networks faster and faster, but there are big gaps and we still have lots of divides. So we've got to work on that. We have ways and means to do that with everyone. Hannah, I am cognizant of the time. Do we want to go over to Q&A? Because there's I think I have an idea that there'll be some great questions for the panelists, for Vint, Hosein, and Olaf.
Yes, thank you, Jane. I will also encourage if some people would like to raise hands instead of writing in the chat, they can of course do this. We have a few questions that were partially answered during your discussion, but I will go over the questions anyway. I will start with a question asked by Nader. Facebook went down the other week. How could the internet fail in that way? I guess any one of you would
Yeah,
like to
I'll take
answer?
it.
Go ahead, Olaf. Go ahead, Olaf. You can.
I'll take it.
You can screw up BGP. We've learned that, and configuration is our biggest challenge. Fortunately, it only affected Facebook, but all the people that depended on it, and that's an important point.
I'm going to draw a picture again. The internet, as we know it, is a network of networks. I have been drawing this picture a few times. Now, what you should remember is that Facebook is just one network of all those networks. And what Facebook did was disconnect itself from the rest of the network through a configuration failure. The whole internet actually remained working. In fact, Facebook, through the routing protocol, said to the rest of the internet, you cannot reach me anymore. And the rest of the internet believed that, because that was what Facebook authoritatively told the technology that is underlying the networks. And so this was not a failure of the internet. This was a failure of one network. I grant you, it's a very big network, and it's a big network on which many people depend for doing business and for being on the internet, for the things for which they join the internet or are on the internet are often Facebook. So the perception of many people is when Facebook is down, the internet is down. But that's not the case. If Vint's employer, Google, goes down, it's also one network on the internet that goes down. A lot of people depend on Google, but it's not the internet that fails. So that is an approach to this question.
And thank you,
Ola.
Olaf. Yeah, go ahead, Hannah. One thing I would say is that Facebook is not the internet, which is a key thing that Olaf was getting at as well. Some people think that their mobile or Facebook are the internet. They're just one party to it. Over to you, Hannah.
Pierre was wondering, I guess this is for Vint, if we can start installing servers on Mars in a few years later.
Actually, we already have servers on Mars because the rovers that have landed are, in a sense, servers who are gathering data and sending it back to Earth for scientific evaluation. I don't anticipate seeing relays other than the two that are already up there until the 2030s, and it's almost certain that we will be sending orbital relays for the interplanetary system during the 2030 period. During the mid-2020s, we will see similar relay systems going up around the moon in order to support both the Gateway and Artemis missions and other missions that other countries are pursuing. So you can anticipate seeing an interplanetary backbone growing literally over the next couple of decades.
Thank you, Vint. I will take Abdullah's question and then we go to the raised hands. Abdullah is asking, can we see internet will be free service in near future?
It's Vint. The answer is that it already tends to be in some respects. If you see some commercial enterprises like McDonald's or Starbucks offer free internet access in exchange for your patronage at their stores. So I don't think, however, that you can anticipate that internet will be free for everyone all the time. There will be different business models, and for some cases, it's a good business model to offer internet. Hotels do that, for example, in order to entice customers to come and stay in their hotels. So you will see free internet, but not necessarily everywhere.
We'll go to Diana. Diana, would you like to open your microphone and ask a question?
Yes, thank you. I would like first to thank the speakers, Vint, Olaf, and Hosein, for very interesting interventions. My question is very simple. I'd like to know what efforts have you been doing for privacy? Because this seems to be a very big deal for everybody. And as Olaf was saying, that everybody thought that Facebook is the internet. So I know there is specific privacy issues for each sub-network like Facebook and on other social media, but what about on the whole internet? Is there any efforts being done to resolve this issue? Thank you very much.
It's Vint. I have one short answer to that is yes, there is work going on to protect people's privacy. I think one of the things that anyone will notice is that in order to use a lot of the applications on the internet, web-based applications, you have to supply quite a bit of information to the website in order to interact with you and transact businesses and services. And I think there's effort going on now to avoid having to leave your information copied all over the internet and instead to lock it all up in a place where you can refer to it and give access to certain content, but to control who has access to it and under what conditions. I'm not suggesting that the problem with privacy is solved merely by that technique, but that's an example of a way of giving more control to users over who has access to information and under what circumstances.
Yeah, I would like to add to that. So one of the ways to solve privacy issues is to offer building blocks that can help resolve privacy issues. But those are not the only way that you address that issue. Privacy is a societal issue that that made its way to the use of the internet. People pay for services with privacy-sensitive information so that ads can be sold to them and so on and so forth. So there is a whole set of stakeholders involved in creating, but also in solving problems related to privacy. And I don't think you can say there will be one technique that solves all privacy issues. No, it will be a piecemeal package of technologies, of regulations, of approaches that the self-regulatory approaches that companies take that will help us towards more control over our own destiny on the internet, which I believe is a very important thing.
There's also a major policy regulatory issue in some places with respect to privacy, and the conversations are ongoing on different fora. And I think we're surfacing issues here related to that application layer. Yeah, Olaf?
Yeah. Of course, yes. Yeah. The General Data Protection Regulation of the Economic Union is one of the first. That's now, how old is it? 5-6 years.
Yeah.
It is one of the first that came in that space, and you see a lot of places around the globe where governments and their citizens and other stakeholders are trying to work out other models to approach privacy issues. Yeah.
Excellent. Hannah.
Thank you, Olaf. Yes, we will take Ghassan's question before going to the questions in the chat. Ghassan?
Yes, I just have a question to Ola when he wrote the shortcut between two nodes on the board. I just want to, if there is some more elaboration on that, like how the way you vision the new infrastructure is that whose responsibility to know or to make a connection with the node. Like if I suppose that means that you would know the destination node, and then if there is a possibility for shortcut, make that connection shortcut. I mean, isn't that at the current infrastructure is the responsibility for the ISP? I mean, just more elaboration on that, how can be possible?
Let me see if I understand your question correctly. Let's go back to this picture.
Yes, yes.
Delete Facebook. Forget that was Facebook. You have all these.
Yes, yes.
You have all these
Yes.
connections, and your question is, who is responsible for these connections?
I mean, that's part of my question, but the more unique one, how do you make sure you would be able to make a new connection with two nodes, because it would make it faster?
Yeah.
Because
Go ahead, Vint.
I have a couple of observations. First of all, one of the interesting evolutions of the internet architecture has been a consequence of the social networking systems and Amazon. And so we have Amazon, we have the cloud-based systems. And what has happened is that they have built their own networks, both to interconnect their own data centers together, but also to interconnect to the internet service providers in a more direct way. You're familiar with content distribution networks, Akamai being one example of that.
edge location, yes.
That is an attempt to move information of interest closer to the user so that it's associated with the user's internet service provider. So we're seeing investment in equipment in the ISP space by third parties who want to offer services that are more responsive to the consumers. And second, those big networks, and let me use Google as an example. We have two very, very big networks. One is connecting all the data centers together. And separately from that, there's another one which connects all of the data center systems to the public internet service providers on a peer-to-peer basis. So we try to be directly connected to many of those 75,000 networks that are part of the internet. So we're seeing a changing architecture, a consequence of enormous investment in infrastructure in order to shrink the distance between the cloud and all of the potential users on the internet. And so that's actually a jump even further beyond what you were asking about, which was how do I make a new connection between a particular pair of networks.
I mean, you now mentioned the solution of data redundancy by making it available on the places that is near to the end user. I mean, that's what CDN is using, right?
Well, yeah. Two things are happening. One of them is the content distribution nodes are being moved closer to the users so that there's exactly one network between them and the service. But then the other thing that's happening, at least for these large scale hyperscale operations, Google included, is to build a network that connects the data center system directly to the nearest ISP to the user. And so that's a very big change in the network architecture, which what Olaf draws is the mesh that we originally thought would be the architecture of the net, but we're seeing it shift based on investments of the hyperscale organizations that get the services closer to the user.
But still, I think that I think that the core of the answer is that still the network operator that is responsible for bringing content to the net, so to speak, makes those investments. So Google has the choice to go to my ISP, make a direct private interconnection, pay for the fiber that goes there, and pays for a box to put in the network. That is the decision of Google. The decision of my ISP to connect to an internet exchange point, pair with a number of the neighbors of closed networks, is a decision of my ISP. So every network, every one of those 75,000 networks, including Google, including Facebook, including Amazon, make their own decisions on how to optimally connect to the rest of the internet or the customers of the data that they want to serve to.
And sometimes they optimize for revenue instead of my good user experience.
Yeah, no, they mostly, I would say, optimize for revenue, because most ISPs are not are businesses that need to make sure that their investments are being paid off, if only to the investment bank.
Thank you. That makes sense. Thank you for Olaf, and really appreciate your time.
if I can just interject quickly and elaborate on in the same direction as Vint and Olaf has said, and the CDN is really an example of how the internet has evolved to meet specific customer demand. And the demand was to be able to stream services and movies closer to the end user and provide a better quality of service at even a lower price. And service providers and network architects met then the demand by redesigning the edge of the network to include these cache engines as close as possible to the end user. So here, innovation is building on user demand and building on the existing internet architecture and augmenting that architecture, not really trying to revamp the architecture and come up with a completely new end-to-end view, as some of the poses that I described are looking for. So innovation based on the customer demand and building block architecture that builds on existing successes in the network evolution is really the key how the internet is going to evolve and succeed to be around us more decades to come.
Thank you. Since Hannah's question was answered by Vint in the chat, for the sake of time, I will jump to Sam'an's question, which was part of what you were just saying. Sam'an is asking, as the internet is evolving in such a fast track, will the internet still be internet?
I think one answer to that question is that there will be networking foreseeably in the future, and because it's already demonstrated such tremendous value. Earlier networks like the telegraph, like the radio and radio telegraphy, and then the telephone system and the television broadcast system, and now the internet, all of them have demonstrated enormous value. So we will continue to explore ways in which people and computers and devices can be interconnected. Whether it's still called the internet 100 years from now, I don't know. But whatever it is, we hope it'll be better than what we have now, regardless of what we call it. And that we would call progress.
Thank you, Vint. Muhammad was asking, similar to Diana, what about privacy and security? Do you have anything to add, or should we go to another question?
Well, we talked a little bit about privacy already, so I won't go into that. But the security issue, of course, is broad. Vint in his presentation already touched upon a number of concerns. For instance, the way that we build systems. And I have to say, I approach security mainly from a technical perspective. And there is a lot of things that we have to agree on in the world if it comes to cybersecurity. There is responsibility of individual actors, of companies and so on and so forth that build software, that maintain software. We have to make sure that we can prosecute people who hack systems and organize ransomware attacks and those type of things. So there is a lot of stuff to do. There is a lot of capacity building needed between individuals, but also between nation states. We have to make sure that nation states agree to a certain set of norms with respect to using cyber capabilities in war and peacetime. So if it comes to security, there is an awful lot to do. There is a tool bag of standards if it comes really to the internet protocols. We have DNS security, we have confidentiality mechanisms like the transport layer security protocol. We have mechanisms to make sure that mail is authenticated in some way so that you reduce spam, DKIM, SPF, those type of technologies, DMARC. So there is a whole set of tools. The thing with security is that we have to get into a mindset of securing things that we use and that we buy and that we develop.
And just to add one thing to that, one of the things that we really need to work on is making security easier for people to use, because if it's too hard to use, they won't use it and they'll be less secure. So building tools and practices that are natural and easy, it seems to me very, very important. Two-factor authentication, for example, is extremely attractive, but if you have 300 accounts and you need 300 little distinct devices in order to achieve two-factor authentication, that's not likely to scale very well. So we need to think about how to design things that are scalable for the benefit of the users.
Vint, that's a really good point about users, and we have a digital footprint course on our learning platform that Hanna and Hanna could make sure, and Nermeen, that chapters have access to. And Olaf, did you want to mention the Global Encryption Day that's coming up? That we have.
Yeah, I can do that. October 21st, there is the Turn It On event, so to speak. We are part of a organization called the Global Encryption Coalition. There's a website, and the Turn It On Day is basically a pledge of people and users to start using encryption in their communication. In our day-to-day business, when we talk to banks, when we buy things online, when we have confidential conversation with our doctors, with our lawyers, when we have conversations with our friends, the confidentiality of that is very important, and sometimes people forget that the internet or that the services that they use do not have encryption turned on. So this is a sort of a pledge to for individuals to look for tools and services that help you with encrypting content and making it secure against hackers, against people that intrude on your data and try to steal it. And I will post the link to the Global Encryption Coalition in our website, in the chat.
I think I got it, but take a look to make sure I got the right link.
Thank you, Olaf. We have a question from Dalia related to the region, actually. What's the biggest policy concern about the internet in the region?
It's Vint. My biggest concern is the fragmentation of the internet that is a consequence of poorly devised policies that interfere with the free flow of information across the network. And I think even though often these policies are well-intended and perhaps aimed at protecting citizens, they have the consequential effect of destroying interoperability and free flow of content. And that, I think, is one of the biggest threats we have to counter by showing that protection of data can be done at different layers in the architecture than just the underlying routing part of the system.
Thank you, Vint. Well, we are starting to run over time. We will take a few more minutes to be able to cover the rest of the questions. We have a question from Zahir. Can we keep one internet apart? Can we keep actually internet apart from political conflicts? He's giving the example of Russia and China.
I wish that the answer, it's Vint again, I wish the answer were yes, but I think that we've already now encountered internet as a place in which conflict is already occurring. Olaf has hinted at that already with his comments about denial of service attacks and hacking and other kinds of things. So we have to accept that the infrastructure is now another battlefield, and we have to come to common agreement that we want to protect that space from becoming a worse battlefield than it already is. And that will require adoption of norms, as Olaf has implied.
Thank you, Vint. We had a question earlier from Nader that I skipped related to access and sustainability, typically related to Lebanon and Jane answered in the chat, just for the sake of time, I'm sorry. Another question from Bahir. What's your take on ongoing content regulation efforts like DSA in Europe, debates around Section 230 in the US and others? In your view, would such regulations have potential impact, unintended consequences beyond content, below the application layer?
For sure, there will be unintended consequences. There always are whenever you try to apply policy to such a complex environment. I think what I worry about more than anything is that sometimes we use the wrong tools at the wrong layer in the architecture to achieve a particular result. And so we need to be much more attentive to how we go about, for example, protecting information. As long as we can exercise really good access control, no matter where the information is in the system, it doesn't matter. You don't need to draw geographical boundaries around things. You just need to make sure that the access control works as intended.
Last question from Zahir. What's the future of providing internet through satellite? Will it change internet model?
Well, it'll make it potentially more accessible if things like Starlink and other efforts succeed, but there will be a question about the economics. Is it affordable? Is it reliable? And that remains to be seen, but I am hopeful that there are many different paths for internet connectivity, the satellite, low Earth orbiting satellite systems being among the newest of the ways in getting access to the system. But we'll still be using optical fiber because of its capacity, and certainly local networking capability like Wi-Fi.
And of course, there will be a question whether those satellite systems will offer a sort of neutral access to the rest of the internet, or give very preferred treatment to, say, their own services or something that we don't know. I actually, there was a question that was sent to me in private chat. Somebody asked me, what is the relationship between the darknet and the internet? What is the relation to each other? Well, the darknet is part of the internet. The darknet is that piece of web servers, of content, of chat services, and so on and so forth, that is not regularly indexed, so seen by indexing services such as Google. So you cannot Google for sites on the dark web. You just have to sort of know from your friend that there is a site where you can play a game, where you can chat with your friends, or you can do malicious activity. Because that is something that we often associate with the darknet, the malicious activities. And of course, collectively, we have to do something against those malicious activity. Perhaps not at necessarily the technical level, but more at the legal level, making sure that we can prosecute people, making sure that we can find the people who commit crimes, and so on and so forth. And so that's sort of the long and short of it. The darknet is actually a part of the internet, but it's really one of the darker corners.
Thank you. There's a question from Dalia that I would happy to answer here in the. There's a question regarding if there's any attempts at the ITU-T after the decision to stop discussing new IP. More attempts to standardize this to date, and the short answer to this is yes. Although the decision was in December 2020 to stop discussing new IP and to reject these new proposals, in the March meeting of Study Group 13, two new proposals came in to standardize elements of the new IP proposal, dealing with deterministic services and heterogeneous networks. And then as far as the last month in September in Study Group 17 that deals with cybersecurity or security, a proposal came in to standardize security guidelines for deterministic services, which is a global service across the internet. which is again an element of the new IP proposal. So there are persistent attempts of the proponents of the new IP proposal to standardize elements of new IP and then build the suite of protocols around the seed that is expected to they try to implement. Hence, they should, like-minded governments or stakeholders should work together to try to raise awareness on these issues and the implications, as we discussed, on interoperability, on internet fragmentation, on investment protection with all the new hardware that needs to be built and trashing the existing infrastructure, on the governance of the internet implications. These have to be taken into consideration, and the awareness has to be raised. There's a meeting of the WTSA, the World Telecommunications Summit, the Standardization Assembly in March of next year. It's the highest authority of standards prioritization and set standard priorities for the ITUT. And there, the governments will discuss these issues. And it's quite possible that new proposals will come in at the meeting itself to try to bring to the forefront again proposals like new IP of family of protocols. So the awareness and continuous effort needs to be maintained. Thank you.
Thank you, Hosein. Sorry for missing this question from Dalia. I will, if you allow me, I will just read and comment from Musallam before running a poll for the end of the call. Musallam was commenting, internet idea is to decentralize everything. However, the natural evolution of the internet is to have strong centralized management. I don't know if you would like to comment before we go to the polls, or if anyone has any other questions.
Go ahead, Vint. Sorry.
Oh, well, no, you shouldn't be sorry. I was happy to have somebody else try to answer that question.
Yeah, so my thought was immediately going to economic consolidation. We see a number of very, very big players on the internet. That is indeed a trend. I do inherently believe that the internet continues to have that promise of decentralization. The consolidation and the growth of the very big companies is a problem that, or is an issue that that has economic effects too, and so economic regulators are eyeing those type of developments. I think that the decentralized nature and the permissionless innovation nature of the internet still allows for new people to join and become big, but it's a challenge. So the internet itself, the network of networks, that is still a network of 75,000 highly decentralized players.
Well, just to add to that, Olaf, I think that nothing stops people, as you point out, the architecture hasn't changed. The fact that there is some concentration doesn't necessarily mean that we still don't have this flexible architecture that allows new players to join. I would point out, by the way, that there's more than one big player, and there's no indication at all that there's going to be any consolidation among the big players. If anything, there may be increasing numbers of big players over time. So the multi-net aspect of the internet is preserved, and everyone is still being served possibly even better than they were before because of the reduction in hopping across the multiple networks to get to and from various products and services. Some of this is an economy of scale that's being exhibited by some of the growth of some of the network service providers. And that's the economy of scale may turn out to be just a built-in mechanism. It's true for other industries as well.
Now you're muted.
Thank you, Victor. I just wanted to say you can keep on discussing for another couple of minutes while I will run the poll. Meanwhile, please answer just to give us your feedback and help us improve. I will also thank Vint for being with us on this call. Thank you very much. Very interesting call and presentation. Olaf, Hosein, and Jane, thank you very much. And the big thank you is for our audience for being with us today and asking these interesting questions. And of course, a big thank you for Nermeen, because without Nermeen's efforts in the region, we wouldn't be here today.
And a huge shout out to our chapters.